We are talking today by satellite telephone to Dr. Nathan Bangs of the University of Texas, Dr. Gregory Moore of the University of Hawaii, and Dr. Harold Tobin of the University of Wisconsin. Doctors Bangs and Moore are aboard the RV Nordic Explorer off Japan, and Dr. Tobin is in his office at the University of Wisconsin-Madison. These scientists have joined their scientific colleagues from Japan in designing a marine survey of active earthquake faults miles below the seafloor off southeast Japan, in preparation for a major international project by the Integrated Ocean Drilling Program to drill through and monitor properties along the seismogenic zone off Japan. So Dr. Tobin, could you please give us some of the basic scientific background for this study and its relationship to the drilling program?
Sure, Don. The NanTroSEIZE project, as we call it, is just this very ambitious program to not only actually drill into the earthquake-generating fault off the coast of Japan, as you say, at a depth of several miles below the seafloor, but also really use that drilling to understand the broader regime of the fault as it leads up to the next big earthquake in this area. And in fact, how it has slipped in past earthquakes and tsunamis as well. So the drilling is really ambitious and very expensive, but one of the key things we need to do in order to drill a hole is figure out where we want to drill it. So we need actual drilling targets for the project. The three-dimensional seismic survey is really the key to defining what those targets actually are. They'll go out to sea and spend a number of days imaging what's below the seafloor, and that image that they generate after a lot of computer processing will give us our targets for drilling so that we really can place what we get out of the hole in terms of core samples in the context of this much larger volume that's imaged by their seismic survey.
Well now, Dr. Bangs, Nathan if I might call you that, could you describe the scientific objectives of the survey and the methodologies that are being used to address these objectives?
Well, the main goal is to understand the earthquakes in this region. And in order to understand earthquakes, you really have to understand the faults that are there and the faulting that's going on in this region. So our main scientific goal or main objective is to try to image where these structures are, where the faults are, what's involved, what materials or what of the structures are involved in the faulting, and get some good images of those structures. And the way we do this is to use seismic reflection techniques, which implement a large sound source that generates a wave. The wave propagates down through the water column and into the subsurface, and we get reflections back from the structures that we're trying to image. And those reflections are recorded on a long streamer, a long array of hydrophones, essentially microphones in the water, that record the returning energy and save it so that we can use it later to reconstruct the seismic images. These are the sound source. We use air guns. We use high pressure air to send out a blast from the ship, and the streamer, the hydrophones are on a streamer that extends out about 4.5 kilometers long behind the ship. So that we can recover, we can listen to all the returning energy over that long span, and we get a lot of very, very weak signals that come back and are recorded that we can use to reconstruct images. And those images, we're looking at structures that extend down to about 10 kilometers below the sea bottom. And the sea bottom is about 2 kilometers, 2 to 4 kilometers below the sea surface. So we're looking at quite deep down into the subsurface.
Dr. Moore, I understand that you've been living in Japan in preparation for these studies while you're on leave for the University of Hawaii. Could you discuss the development of the collaboration with your Japanese counterparts to undertake this survey?
Gee, Don, you know, our collaboration with this group of Japanese investigators goes back almost 20 years. We started out with a joint program, again with colleagues at the University of Texas, in 1987, when our main Japanese contact, Professor Asahiko Taira, was at the Ocean Research Institute of the University of Tokyo. We carried out a two-ship seismic reflection operation and also collected regular 2D seismic data. A few years later, in 1990, I joined Professor Taira, who was co-chief scientist on ODP Leg 131, where we drilled the first hole through an accretionary prism all the way down to the top of the descending oceanic crust. I then was co-chief scientist with Professor Taira in the year 2000 on ODP Leg 190. Dr. Taira invited me over to for my first extended trip in Japan in 2001. I spent a semester as a visiting professor at the University of Tokyo. And since that time, we've been working to develop this NanTroSEIZE program. I've made many, many trips over to Japan, working with many colleagues over there. A couple of years ago, Dr. Taira joined the Japan Agency for Marine Earth Science and Technology and developed the program that we're now working on, the Center for Deep Earth Exploration. That's the group that I'm now working with as an advisor to Professor Taira.
So in other words, these programs, something on the scale of this 3D survey and the follow-up drilling, take literally years or decades to develop.
That's right. This particular, I guess you'd have to say the NanTroSEIZE program was first developed at a workshop that Nathan and I attended in Tokyo in 2001. So we're now 5 years after that, and the drilling program will start in another year or so and continue on for several years beyond that.
Wow, it sounds like some program. Dr. Bangs, or Nathan, how does funding for this scale of project get started, and how does this program relate to the Margins program, which I know is an initiative, a research initiative funded by the National Science Foundation?
As you can imagine, this is a very expensive project, and it really requires a large amount of the science resources that are available to scientists or the earth scientists, and so we've used money from sources from Japan. They have a very big interest in this, and they've contributed a significant amount of money to the project. And there's also money that's come from the National Science Foundation, and that's through the Margins program that you mentioned. So it is a very expensive effort, and it requires a substantial amount of money. And so this becomes a fairly major part of the Margins program. And the Margins has 4 main initiatives, and one of them is to understand earthquakes or the seismogenic zone. And the NanTroSEIZE program is the biggest it's the main site that is the focus of the NanTroSEIZE program within Margins. And so the Margins program is focused on several things, but this is a key thing for understanding. This is a key region to understand the earthquakes for the Margins seismogenic zone initiative.
Now I know there's the Margins portion that comes in through National Science Foundation, but I also know the Integrated Ocean Drilling Program is also involved, is it?
Yes, they are. They support from the National Science Foundation. The Ocean Drilling Program supports some of this work. The Integrated Ocean Drilling Program, which is the sort of the structure for the drilling, is also behind this in terms of supporting it and making sure trying to make sure that it happens.
So this program is on such a large scale. Not only does it involve several different groups within the National Science Foundation, but also collaboration with international scientists and funding agencies as well.
Absolutely. This is a big project, and it really requires a lot of coordination and collaboration from a variety of institutions throughout the U.S., Japan, and even other places in the world.
Well, I want to thank both of you for taking the time today to inform us about this upcoming voyage, and I certainly wish you the best of luck in reaching all of your objectives.
Thanks, Don.
Thanks.